Microservices tutorial series. In this tutorial, we are going to learn with microservices development and deployment process using hands-on examples. And in this series, we are going to have with multiple videos. In the very first video, I am going to give you an introduction. If you like this video, like it, subscribe to my channel for new updates and share to the people who might need these topics. So to start with microservices, we will be also covering with Spring Boot and Spring Cloud modules for implementation. And in this series, I am going to cover with microservices implementation, monitoring and virtualization using Spring Boot admin and as well as Eureka, and designing microservices components and standardizing the ports for deployment, creating microservices using with Spring Cloud config server and using Git repository, and load balancing with ribbon, service discovery and lookup process, and designing with Swagger API for documentation, and circuit breaker using Hystrix, request handling using with Zuul API gateway, and microservices monitoring and distributed tracing by using Sleuth and Zipkin, and fault tolerance and Autofailover by using Fallbackmethods implementation, and implementing Spring Cloud Plus. So let's get started with introduction to microservices. So what exactly is a microservice? So microservices are initially known as like micro web services. Microservices are small autonomous services which works together. Actually, the microservices have emerged from the concepts called domain driven design, continuous delivery, on demand virtualization, infrastructure automation, and small autonomous teams can work together. So if we can compare with the monolithic service, so monolithic service, the architecture would be like the user interface and the business logic and the database logics. So all the application is created as one single code base, and one single var file will be holding with all the modules for the application. Maybe designing the application is easy, but it cannot be aligned for the business change request whenever it is required. As per the market request, we cannot align the application. Coming to the microservices architecture, the application can be designed by decomposing the bigger monolithic service into the smaller microservices. And here developer will be having a flexibility to choose the stack of technologies to design each and every microservice without giving an impact to the other services. And microservices are loosely coupled, where each service can be talk to the other service by using a REST API calls in a loosely coupled fashion. Microservices are small and focused, and they are autonomous, they are specific to the task which is designed for, and tight cohesion. Microservices are language neutral. It can be developed into multiple languages with multiple frameworks, and especially learning microservices, the learning curve is very short, and most of the top IT organizations, they are already implementing with the microservices architecture to design the applications like Amazon, eBay, then Guild, Netflix, PayPal and Twitter. If you can look into the monolithic service, monolithic application contains the whole functionality of the application into a single program, which we are calling it as a var file with a single environment. Means you will be well designed with a stock of technologies for UI, then backend, middleware, a database. All the modules of the application has to be developed with the same set of technologies. Let's say if you can take an example, any e-commerce shopping application. So buyer's profile, catalog management and the cart management and further any other modules into the application has to be accommodated into the same var file. So this is developing is easy, but which cannot be enabling with your continuous delivery process, especially into agile based applications with DevOps culture. We cannot accommodate monolithic services for continuous delivery process. Coming to the microservices architecture, so the application can be designed by decomposing into multiple services, and each service can talk each other by REST API calls, where each service can have a choice of front end and then back end and the middleware. So like buyer profile can be designed as a separate microservice, and all the microservices can be talked together by using the API gateways. So there are multiple features we can implement along with the microservices design, that is like monitoring and tracing the microservices applications, and then circuit breaker, and then fault tolerance, and then auto failover and load balancing. So all these features can be added by provided with the Spring Cloud modules. If you can look into the advantages, like microservices are more flexible to develop and deploy the services independently, and they are highly scalable. As per the workload required, we can scale up the application by provided with the number of instances, and it is very cost efficient to design into microservices architecture, and time for every operation reduces. Like while you design a microservice, you do need not wait for the other services to be completed with. So microservices maintenance, like updating your service features with can be done easily without giving any impact to the other services. Adding and deleting services to your application into a large system is easy and efficient. It will not give any impact for the other services, and they are enabled with a fault tolerance by using Hystrix and other plugins. And the technology stack, the developer have a choice, like you can design different services with your own different web languages, and as well as databases and servers and UI technology. And coming to microservices are enabled with continuous delivery, where by using your CI/CD pipelines, Jenkins, continuous integration and continuous build tools, you can use it, and you can enable with a continuous delivery. Testing and deployment can be done in isolated fashion by using microservices, and microservices also enables you for achieving a quicker user acceptance test. And by using microservices architecture implementation, it is easy to adapt the market changes with your application, and business can be aligned according to your application architecture. If you can take a simple mobile banking application, like you can decompose your application feature into multiple services, and each service is nothing but you will be designing with a Spring Boot project, which is easy to develop with, and all the services can be accommodated into your config server and your Spring Boot admin, where the number of services available and the number of instances available you can administer easily, and you can maintain with the load balancing and other features of microservices for your application. It is a simple example for your microservices use case. We will be looking into all the features of microservices, like how to configure Spring Cloud config server with Git, and then monitoring with your instances by using Eureka Netflix server, and load balancing with Ribbon, and generating the Swagger API using with documentation, and then service discovery and lookup, and coming to request handling by using Zuul API gateway, and then by monitoring your microservices collaboration by using Sleuth and Zipkin, and by applying with the fallback methods for your applications to handle with the fault tolerance and auto failover feature, and also how to implement the Spring Cloud bus also we will be looking into our following videos with the hands-on examples. That's all for this introduction part. Thank you.